Welcome to all of you. Now we discuss Numerical Practical 8, second method for root finding of a nonlinear equation. Semester 6, paper CC 14, practical with honors in mathematics. What is the second method? In numerical analysis, the second method is a root finding algorithm that uses the succession of root of second lines to better approximate the root of a function f. Here, this is the method, this is the function, this is the red curve, this is the function y equal to fx. And the root is this, where the function fx cuts the x-axis. This is the x-axis and this y-axis. And this x0 and x1 are two initial approximations of the root. Then this x0 point, so this point is x0 fx0 and this point is x1, so this point is x1 fx1. So join these 2 points, x0 fx0 and x1 fx1, and so we get, and this is the second uh, line, and finding this the recurrence, we find this we get, this is the y into this, the picture, the slope intercept form of the equation of this line. So this is the line equation of this line, this, and the the equation of this line is this, and from this we get x equal to this, and if we put this y equal to 0, we get x equal to this. So this x is called x2, and this is the x2, where this second cut the x-axis at this point, this x2 point is the second approximation of the root. And then this point is x2, so this point on this curve is x2 fx2, and this point, previous point x1, previous approximation x1, and this point x1 fx1. So next join these 2 points, this x1 fx1 and x2 fx2, and this is the new second, and this line cuts the again via x-axis at the point x3, and this is the third approximation of the root is this, and this is the process of this second method, and this convergence, rate of convergence is this 1.618 and so on. Now the programming of the second method, this date, problem 8, write a C program to find the smallest positive root of the following nonlinear equation using second method, correct to 5 decimal place, exponential x square plus log to the base e x square plus 2 equal to a into bracket x plus 1. Here log to the base e, in C programming you can write log log of this to the base c, that is the natural logarithm, or ln x, and for common logarithm use log 10. Log 10 is the common logarithm. We write here this log 10x represents the common logarithm, that is the base 10 in C. And this is the problem where a is this equal to 3 plus r by 10 if r less than equal to 5, and a equal to 3 plus r minus 5 by 10 if r is greater than 5. So when r equal to 0, 1, 2, 3, 4, 5, you put this a equal to this value, and when r equal to 6, 7, 8, 9, you put this value of a is this. First, to define the function float f, the arguments are float x and float a. So this function is this, is equal to exponential x square plus log to the base e x square plus 2 minus, this is the left hand side, this equal to right hand side equal to 0. So this is the function fx equals to 0. I convert this. So minus a into x plus 1. The main program is this, floating variables are a, x0, x1, x2, and this error, that is 1.0 and e to the power minus 7, e to the power minus 7, that is, sorry, 10 to the power minus 7, 10 to the power minus 7, that is 0 0 0 0 0 0 0 1, and h. An integer variable are r, the last digit of your roll number, and n equal to 0. N is the step length, sorry, step length. The L is the step step counter. N is the step counter. Step counter. N is the step counter. So initially, step is 0. Print if this is the enter the value of the r, that is the last digit of your roll number, and scan d, this percentage d, this equals to percent r, and this is the step column. I mean, because if we next going to the loop after, uh, if x is negative, and then we going to the go to the step, this step actually, because we want to find the smallest positive root. So when x root is negative, we again enter the new approximations of the roots, two approximation. Next, printf, we enter two initial approximations of the root, x0 and x1. X0 and x1 should be the better approximation, should be the closest approximation of the root, so that the method converges. Otherwise, this method diverges. The x0 and x1, and if r less than equal to 5, a equal to 3 plus r by 10, and else if r is greater than 5, a equal to this. But I suggest that on the exam, you must put this value of a according your r, last digit of roll number, and then simplify this function this in this definition, so you can avoid r less than equal to 5, r greater than equal to 5. About this, first we put the value of a initially in the function, and then calculate this the function this in this definition of the function. Next, while absolute value of x0 minus x1, that is these two approximation, absolute value of these two initial approximations, root of this greater than error term, this is the 0.000001. This then h is equal to x1 minus x0 into fx1 uh, by fx1 minus fx0 by this formula. This is the formula of this, this is the formula x1 minus fx1, and this into x1 minus x0 by fx1 minus fx0, and value this x2 is equal to, next value is x1, new value of x, this x2, this x1 minus h, and again this x0 is the x0 value, new x0 is the previous x1, and new x1 is the this x2. Store the variable x1 in the variable x1, this new value of x2, and again calculate this h, uh, while absolute value of x1 minus x0 is greater than error term. And this the n plus plus is the increment of the step, that is the step counter. And if x0 is negative, and then print the root is negative, and go to the step, again go to the step this step, or you can write here anything this this printf this new approximation of this root, and we get the smallest positive root is this, and 10.5 is the 0.5 is the after decimal place, the formatting of this x0 is 10 point, total number of digits is 10, and 5 is the decimal point to 5 decimal places. So first save this and this, compile, and then run this problem. Enter the value r, say 9, and enter the two initial approximations of the root x0 and x1. We put x0, enter 1. So here we get the root is minus 0.42, and this which is negative, and we uh, want to get the smallest positive root, so we again enter the x0 is 1 and 2. So we get this is the smallest positive root is 1.38091, and this is the smallest positive root of this function. Now we Desmos app, we apply the Desmos app, this Desmos app here. First, this x e to the power x square plus ln x square plus 2 minus 3 plus r by 10 into x plus 1. And r runs from 1 to 5, 1, 2, 3, 4, 5. So first we of this curve, this when r equal to greater than 5, this is the, so first we red curve is this here. R in this problem, r is the, we get here r equal to 9. So here we run r equal to 9 this problem. This is the green curve, r equal to 9. Here choose with r equal to 9. So we get these two roots where cuts the x-axis. This point 1.381 by Desmos app is the smallest positive root, and from this we get 1.38091. So this is the 1.381. Okay. And this is the negative root is this minus 0.42 by the Desmos app for r equal to 9 minus 0.42, and this again if we run this problem when r equal to up to 1 0 1 2 3 4 5, this function is this, say r equal to say 3. Here you can change this r equal to 3, r equal to 2, or r equal to 4, say r equal to 4. So when r equal to 4, we get value is 1.381. So again you can run this problem, compile and run. When r equal to 4, enter the value r equal to 4. Then enter the value x0 is this 0 and 1, and the minus 0.42 is the negative root of this problem, of this function. So r equal to 4, we get this minus 42 is the negative root here. And when so in again enter the two initial approximations of the root, say 1 x01 and 2, we get this 1.38091 is the next smallest positive root of this approximation. So we get this is the 1.3801 when r equal to 4. So when r equal to 4, we choose this function, and r equal to 1 2 3 4 5 for this function, and when r equal to 6 7 8 9, we can choose this function. So this is the Desmos app, and this is the word file. This word file in this problem, and r in equal to 5. Sorry, step length, not is step length, this is the step counter. Step counter equal to step counter is the problem, and we here output is this r equal to 9. Enter the two initial approximation of the root x0 x1, and this 0 1 negative, and this is the when again negative. So we want to get the positive modest positive root. So we again the change the initial approximation 1 and 2. We get smallest positive root is this. Value of xn plus 1 is the h, and value of xn plus n plus 2, that is the xn minus h. And so this in 18th step, actually here step counter is this here 0 1 to 8, and again here step counter is this 9 to 19. So from the beginning is 0, and this is the 19 step counter. You can change this by some rectification of this problem. And thank you for watching this video.